Hello, my name's Anthony Betts, and my topic is roof geometry, and that's obviously in the DCG syllabus. It's in the topic of um, surface geometry, which is right here. So roof geometry is in surface geometry. Um, so my portfolio, since it's going to be digital, I'm going to create as much videos as possible, as obviously reading the words from a PowerPoint isn't, um, let's say, you don't get, you really don't understand where the student is coming from. And I actually have a mic and a tripod, so I was thinking, since I have those, I can actually create videos with good audio, and obviously the camera, like, you won't be shaking. So I'm going to create loads of videos in this portfolio, and the first video is this video, and it's going to be going through the syllabus of surface geometry, and I'm going to just talk about it and how it relates to my topic and why roof geometry um, does deserve to be on the syllabus, because roof geometry is very important and does deserve to be on it. And it's actually one of the questions I actually enjoyed doing it for the Leaving Cert. So while I'm going to go through this syllabus for this part here, I'm also going to have a bit of writing I actually printed off, and I'm going to talk through it while we're doing this. There's obviously some spelling mistakes. I made a mistake. I'm dyslexic, so my mom helped me with some things just to fix up. So, yeah, let's jump into it and start going. So, roof geometry. Why is it important? Well, it's important and it's very significant in this syllabus, as it helps students to build on past skills. So, some past skills would be drawing, plan, elevation, and end view. So, that's obviously orthographic. So, if students can build on that, that's obviously something what we want. So that probably will be for the ordinary levels. Obviously, the higher level students will have to do it as well, but um, for this part here for syllabus, it won't. The orthographic won't be obviously one of the points. See the bullet points. It won't be over here like orthographic or whatever. Um, so if students can build on a past skill, it'll be great, because it's kind of one of the first things you need to do when answering the question. Uh, the other thing I want to say, as well as building past skills, also this topic helps you to learn new skills such as dihedral angles and true shapes. So students would have learned dihedral angles and true shapes. They would have learned it, not say at all, because they would learn some of it in developments, as developments is similar to true shapes. And I'm actually going to talk about that specifically in another video in this portfolio. It's actually going to be on this little dice. This is going to be another video in section 1. So you'll see that later on when you're assessing the portfolio. So new skills such as the triangles and true shapes. So obviously, when you can see here in the syllabus, I'm going to scroll down a bit. Students should be able to determine dihedral angles between adjacent plane surface forming solid objects. So obviously, dihedral angles between adjacent surface forming solid objects. So that's a lot of words in that most people wouldn't really understand. So triangles, that's something new students will learn. And when they mean between adjacent plane surfaces, they mean between two. They mean between two. They mean like when you look at a roof, it's not just one flat line. So let's say I actually have this question already done. I'm going to use this as an example. Just give me 1 second. It's on the ground. So if I go on to here, This is actually a leave cert question, and this is obviously it says it's an Irish building structure. So this is an Irish building somewhere. I've never seen it because I'm from Waterford. I don't know where exactly in Ireland it is. But when they say draw the given plan elevation, okay, so when they say draw the given plan elevation, that relates to what I said about Pascal's. And the next question they asked you was determine the huge angle between surface A and surface B. So I have this question done out. I'm going to bring this camera around a bit now so you can see it. Hopefully, when I hold this tripod, it will still say similar. So this is the same building that they showed in the picture. So when they say find out the angle between this here, A and B, when you look in the plan, there's A and there's B, and they want to find out the angle between those two surfaces, and that's what they say. They say determine the angle between adjacent plane surfaces forming a solid objects. So when I say that was a lot of complicated words, I do not say that myself because when I first read it, I was like, what did I mean by that? But basically, they mean, I come back to here, what's the angle between these two surfaces? So obviously this is the 3D of it. So this is A, and you're like, oh, where's B? Well, B is actually on the other side. You can't actually see it because the point of view where you're looking at, but B is actually, see this line here? This line right there, and this line right here, that's part of B. It's just on that side. So I pointed at this line and this line, that's right here. This line, and then obviously then this line will be here. So they want you, I want to get my two set squares to explain the adjacent surface plane. So let me get them my two set squares. Oops, I'm gonna just back out of this. I clicked something wrong. So imagine this was the roof we looked at in the question. So if I pop up here back in PowerPoint, see the roof? Imagine zoom in a bit so you can see it. I'll just increase it more so you get a better idea what I'm talking about. As being dyslexic, I'm not really the greatest talker, but I usually say the same thing a few times and I emphasize on it, and usually people will understand what I'm saying. So this, where I'm pointing right here, that's obviously one side of the plane, and that's the other side. So if I use my set squares right here, so this is one side and this is the other side, when they meet right here, they want to know what is this angle right there. That's what they mean by, I go back to the syllabus, when they say the huge angle between the adjacent plane surfaces, they mean what's the angle between this plane right here and this plane, where they meet right there. If I have it right here, if this is this set square and this is the other one, if you put them together, so if I go boop, put them together, if I turn it up, so now this is going to be like a 3D visual. I'm going to hold this with two hands, one hand I meant, so I can show you. Oh god, right there. If I get the camera, when you see these planes touching, they want to know what this angle is right here. not, yeah. So I'll do two ends. So when they meet, they want to know what the angle is. Hopefully you understand that. I've said it a few times, and hopefully you can understand what I'm talking about. So that's obviously very important. And I said in my little piece of paper I printed off here, I said they'll also learn true shapes. So they say that in the syllabus, it gets closer and more focused in. Let me just move my tripod. Here you go. So in the higher level, they talk about ductworks. Yes, that I'll talk about that later on. Surface developments. Oh yeah, here for higher and ornate, they say surface developments, and they mean true shapes. So if I go back to the question in an exam paper for the leaving cert, let me just zoom out. They say determine the true shape of surface C. So obviously in the question I showed, I'm going to show this later on of how to actually find each of these, but that'll be later on for section I think that's section 3. Yeah, but this is section 1, so I won't be talking about how to actually get it. But here, this is surface C. They want you to find a true shape of that, which will actually be right here. This is the true shape. So it's in the syllabus. Finding the true shape and the dihedral angle. So why do students need to learn these new skills, and why does it need to be on the syllabus? I've found out that surface geometry, which my topic roof geometry is in, gives students knowledge and understanding of the manufacturing environment. So manufacturing environment is in engineering, it's in architecture, it's in design and packaging, which is very important, especially in the times we're living today, when the environment is a big issue and concern that we have, as we don't want to obviously waste anything. That's really it.